only these two basic equations for solving two unknown x and as. The given environmental condition is used to determine the minimum cover thickness. So we need to do this. We need to know. First, we need to assume the cover thickness, complete cover. So the basic process is to first assume the AS. For beam, normally AS equal to 40 millimeter for one layer reinforcement, and for two layer reinforcement, AS 65. For slab, generally 25 or 35, something like this. Once you go to the AS, then you can calculation X. So X is the result. So how can we get this X? And what's the meaning of X for this X?
So the meaning of the X.
See, for this question, everything I told you asks you to calculating the AS or the reinforcement. So now we don't see this process. So if you need this question, how to do it? What's the basic method? So we see. This is the question. The moment I told you is 120 is the environment condition is type 1, and the safety level gamma 0 is actually safety level is 3. The dimension of the section concrete is 20. And the steel reinforcement is here is 235. Ask you to calculate AS. So do you know how to calculate AS? Everything I told you.
Yes.
Yes?
Yeah.
Okay.
A0 equals 8.
So tell me, what do we do for the first step? How to solve this problem?
You first check inside the table and find the value for the distance, the FSD1 from the table, and then you write the general formula for this one.
So this is the basic situation. Everything I told you, just ask you to calculate how much reinforcement we need.
Yeah.
So if you meet this, if you ask you to do some combo like this. So step 1 to the what? Step
1 design. Find it.
The materials you use.
So first one to check the table, the strength of the material. Yes, you can. Then step 2. Calculation. So we see this process again. Actually, generally, first step, you need to assume AS. See, still remember what's the meaning of AS?
S is the distance.
Area.
The distance between the bottom to the middle of the steel.
The middle of what?
The middle of the steel bar. If it's one,
Yeah.
it is the middle. But if it's two line, the middle of the two line to the bottom. Or we can say that AS equal to H minus H0.
Yeah, but AS is not the middle of the. Actually, it's
This is area cover section.
not
The center,
the central actually the central of
the center.
reinforcement. Yeah, because if the two layer, the diameter is different, so of course it should not be the middle.
No, or the center.
Yeah, actually the central of the reinforcement. So for this situation, everything I told you, dimension, the material, and the outload, after calculating the reinforcement area, then if we solve this problem, first step normally you need to make the assume AS, this AS. Actually, this AS is the meaning of this. AS is the action point for the tensile force to the outer surface of the beam. Because the calculating, I'm not sure if you still remember or not, is sigma F T F or Fs D and
Sigma
A
AS
AI and I. Actually,
Sigma
no. It's A. No, that's A is no I. It's AI.
no, it's there is also
In the top is equal to this FSD AI LI.
oh yeah. Yes.
So it's not only related to the area or the geometric for the reinforcement, but also related to the material strength. But normally, this FSD is the same for this different layer.
The same steel.
Same steel, HRB 335 or HRB 400, something like this. Normally, it might be the material for the reinforcement normally use the same type. Because if you use different, maybe this is the HRB 335, this HRB 400, it's easy to make mistake, especially on the construction side. For the worker, it's quite easy to make it mistake because you just see the outer surface of the reinforcement. You can very easily. It's very difficult to know which one is which one. only is the diameter, maybe the smaller, the larger, is easy. So basically, this formula we can remove this. It's just this all together, all the area layer 1, layer 2, all together. All we see is I, L, or I, T, something like this fields. I means the layer, T is the value of so you know this meaning. So once you got this ES, once you know the ES, we got this H0. Actually, our purpose is to got H0. H0 is the effective height for this beam. Because in the calculation formula, we need to got H0. This is the basic formula. Gamma 0. So gamma 0 MD equal to FCD dx H0 minus half x. So how we got this? Formula?
Quadratic equation.
How we got this formula?
Is in the
Yes, in the book. Well, what's the basis for this formula? Why we can't write the formula like this? Gamma 0 MD. What's the meaning of gamma 0 MD?
gamma 0?
Gamma 0 is what's the meaning of gamma 0?
Gamma 0.
Yeah, gamma 0. What's the meaning of gamma 0?
Gamma 0 is the
Sum of the moments of the tension force.
No. Gamma 0. What's the meaning of gamma 0?
Only gamma 0.
Yeah.
is the pre-stress area.
Hmm?
The stress area. But I know that formula is like I said, quadratic equation.
This formula is what?
Equation. Quadratic equation.
So FCD x. The conversion height is x. FCD, the compression strength of concrete. B is the width of the beam. X is the compression height. So this is the compression force
In the area index.
For this
Area.
compression area of the concrete. And H0 minus half x is what? H0 minus half x. What's the meaning?
Is a restressed area. No, reinforced area.
Huh?
Reinforced area.
Reinforced area. What's the meaning? H0 minus half x.
We take the distance, the restress distance minus the half of the distance of the concrete distance.
Yeah. I mean, what's the meaning in this? So this part, F3BX is the compression force. H0 minus half x.
Compressive area? Compressive.
It's the arm or the compressive force to the tensile reinforcement.
Oh.
So totally this is the moment, the resist moment of this section induced by the internal force. And this part, gamma 0 md, is the external moment induced, or the moment induced the external load. Gamma 0 is the important factor of structure. Is the important factor of the structure because we got level 1, level 2, level 3. Level 1 means this structure is very important. So the gamma 0 equal to 0.1, 1.1.
No,
1.1. For structure level 2, gamma 0 equal to 1.0. Level 3 equal to 0.9. 3 level of the, according to the result of the structure destroyed. Very serious. There's no structure. I think we have told this many times, gamma 0.
Yeah.
But I should say gamma 0 MD represent what? What does it represent? Gamma 0 MD.
Empty.
Gamma 0 MD, what does it represent?
Gamma 0 MD. So MD is the moment, bending moment induced the external load. So gamma 0 is just some of the coefficients to strengthen or to just beside this design force, design moment, to improve it 10% or just don't improve it or just make a little bit 10%. It's depends on your structure if it's important or not. So gamma 0, 1.1, 1.0, 0.9, this
Level 1.
level 1, level 2, level 3. So that means if your structure is very important, besides the normal, the MD, the external load movement, so because this movement MD actually is the combination result of different loads. For the structure of level 1 very important, then we make this external load improve 10%. Then make this structure more stronger. So this formula, this is the basic. This is one of the basic formulation we use to calculation. Actually, we have another two basic formulation. Do you still remember? We got three basic formulation for this section to do this design. So the first one, what's the first one? First formula.
FCG
F C D Bx equal to FSD
times
AS. This is the compressive force equals to the tensile force. So similar as this one, gamma 0 MD equal to FSD AS multiply all of this H0 x0 minus half x. So this is another basic formula beside this one, because there is 3 formula. So those basic formula you don't even need to just remember, you just understand this figure, then you can just write down it very easily.
The difference between FCD and FSD.
FCD, FSD.
Yeah.
C means concrete.
Yeah.
FCD actually is the compressive strength of concrete. FSD, S steel. The tensile strength of the reinforcement. And we also got another FTD. FTD, normally we use it to replace the tensile strength of the concrete.
Of the concrete.
Yeah, the concrete. So now, from this basic formula, we got this. Once we assume ES, we got, actually that means we got H0. We got H0, then we can go to the AX, X is the compression, the height of the compression area. So remember how we got this X. Actually, it's just like this: AX squared plus BX plus C equal to 0. This? Yeah. Just use this formula. Because in this formula, 1x here, another is here. So it's just multiply this, you got this x squared, x, and c. Then you got this, how call this equation? Quadratic equation. So this is the basic formula, basic solution of this type of equation. You see, the purpose of assuming AS is to get H0. Once you got H0, then we can find the X. Once you got X, then we can use this formula to get AS. So why we use this formula? Why we don't use this formula? You see, in this formula, X we don't know, AS we don't know. And also in this formula, AS we don't know, X we don't know. But in this formula, only X. That's why we use this formula to get X. Once you got X, then this one, also you can use this one. You can get AS. So once we got X, the compression height, then normally we need to do this step, check X if it smaller than KCB H0 or KC smaller KCB. So what's the meaning of this? Why we check these things? Why we check this? Remember? Once we got this height of the compression area, why we check this?
For the boundary condition.
Boundary condition. KCB is for the boundary condition. Boundary for what?
Boundary for the film.
For the over reinforcement and the pro reinforcement.
This one is the under the normal.
Yeah, the boundary. So sometimes if you assume AS and you got AX, if the X larger than this KCB H0, that means your design is still over reinforcement. So if it's over reinforcement, then the following formula is different. So we check this X to see if it's smaller than this KCB H0. So follow the following step, we use this formula to get the AS or the reinforcement. So this is very simple. Once you got the AS, then you need to design what type of the reinforcement you use, the diameter and the number, how many. So normally the real reinforcement you use, the area should at least large or equal to this result. Cannot be smaller than this. Because the diameter is fixed, 20 to 24 something. So it's very difficult to make this area just equal to this value. Normally it's a little bit larger than this value. So depending on what type of the reinforcement you select and how many you use. So once you determine what type of the diameter and how many you used, then you can calculate the real reinforcement ratio. Now you need to use the real reinforcement area AX, not this result, this is the result you calculating. You should go to the real AX. And actually, in this step, another value you need to calculate is this two AS. Why is this capital AS? Another one is small AS. Because at the beginning we assumed AS. First step we assume AS equal to 30 or 40. But once you determine the diameter and the number of the reinforcement you used, you need to calculate the real AS. Then you use the real capital AS and the real H0 to get the reinforcement ratio rule.
The AS we have after the AS we have, it will be different from the AS from then. The AS will be found with the AS area.
Yeah.
It will be different. No, the one who is downside, it will be very different.
This one?
Yeah, it's different from that one.
Of course, I have told you. This one is a theoretical number that you will need. This one is the real area you put in the beam. Normally, this one is larger than this one. It's very difficult to make this one just equal to this one because the diameter of the steel, you cannot just say the diameter is a 20 point something. It's 21, 20, 22, 24 something because the diameter is from different type is fixed. So the area actually is fixed. Different type have different area, different diameter from different area. So that means you can. It's not easy to got this to just equal.
So the diameter of the steel we use, what is how we select? What is based on what the selection we do it based on what? Based on what?
Based on what?
Yeah, the selection of the steel.
Of course. You see, normally if you can just use one layer, it's better. Because some situation you can use one layer, or you can make it two layer. If you use a smaller diameter, maybe suppose one layer we use 3, maybe you need 6, then you put 2 layer. But if you use a very large diameter, then maybe you can just put it in one layer. Actually, if you can make it in one layer, it's better to use one layer, not to use 2 layers or even 3 layers, because the one layer, the central position is this position. That means the arm for the force is larger. If you use 2 layer or 3 layer, generally AS become larger. AS become larger. That means this distance h0 minus half x becomes smaller. That means the arm becomes smaller. So that means the effective or the reinforcement is smaller. So the basis, the principle
Selection.
for selection. Of course, you should make the real AS large, equal or larger than your theoretical result. And for this, if you can use a large diameter and put it in one layer, it's better than smaller diameter in more 1 or 2 or 3 layer. I'm not sure if it's clear or not. Because once you finish the calculation, once you go to the AS, for this AS, you have many choices. You can use diameter or 30 or 20 or 18 or 15, something like this. You have many choices of the reinforcement with different diameter. Smaller diameter, that means the area of each steel is smaller. That's you need to manage the number of the steel become increase. That's maybe you need two layer or 3 layer to arrange this reinforcement. But if you use large diameter, maybe 1 layer is enough. So you see this.
So the AS will be given on the exercise. The AS. As you said, that the AS.
Yeah.
Is different of that one.
Yeah.
The first one. So
Yeah.
it will be given.
Yeah.
Oh.
You see, you have all got this book. So we see the 319 table 126. You see this here. You see this table. Appendix table.
Page.
319. So suppose we go to the AS, we use this formula, we calculated the AS equal to 1.195. I give this value, or maybe this is a little bit smaller, something, or 2. Suppose from this formula, we got AS, the area equal to this square millimeter. So now ask you to design what type of reinforcement we use and the number. So everyone can make this a little bit larger. 33, 39, 30195. The A is like this. You just use this table to design this. What type of diameter we use and how many. Everyone, you can just check this table and do this design. We are in choice. Everyone has different choice. To see how many or what type of reinforcement we can use. So suppose that we need the result with the S we need is 30195. And based on this table 1 to 6, select what type of the diameter, what type of reinforcement we can use, and how many.
Can you use it?
22. What 22?
8. 8.
What's 8?
The diameter is 22.
No, you just tell me, just write the diameter and the number, how many, what type of diameter you use, and how many you use.
How many pieces?
Yeah. You, of course, you can choose different diameter. Maybe you can use one is diameter 30 or one is 20, something like this. To make sure to make this area. And you should another principle you should remember. The arrangement of the steel reinforcement should be in this section should be symmetrical. So see, if it got five reinforcement, or you can make it in one layer is 5, or make it 2 layer. The first layer is 3, another layer is 2. So, but you should make it symmetrical.
Awesome.
No, 3019195 is only just 4, which one you use? 3041, you see? It's 5 numbers, just 4 numbers.
Oh, 195.
Yeah. So you just do your choice, or write on the blackboard. Everyone can write the choice. Actually, everyone has different. This is not only on my answer. Everyone has your design answer. It's not just 1 plus 1 equal 2. So from this table, you can do many combinations. So we just do this exercise to choose your design, to do your design. Give you this area and do your design, do your own design, what type of reinforcement we use. And draw this figure and tell us the diameter, the number. So it's 313 or 315. 12 break, and then you do your design.
So normally the second one is bigger than the first one.
No, the first layer.
Oh, the first.
Normally is the biggest one, all the same as the second layer or third layer. Normally you can. But you cannot make the second layer larger than the first layer.
So we can choose the one which is lesser than this one, 7240.
No, not smaller than this one.
But more than 7240.
Yeah. The value should be larger than this one.
Oh, so meaning we will have to use our own values.
What?
We will have to use our own values for the area.
Yes. So for area know, for this design, everyone has their own answer. So just draw on this blackboard and see. Yeah, and then when for the rib, normally we use this symbol. This rib the reinforcement.
Ripped.
Rib.
Oh, so I should use this one.
Right side.
This one?
Right.
Yeah, it has a little bit like this. And the one part is to the what the B. You should calculation actually once you got the design, you should calculation the distance, the cover thickness and the space distance between these two steel bar. Normally should be larger than the diameter.
Oh.
So you calculate if you use this 6-1 layer, so the B, how much should be B? If the B is larger than of course in this question I didn't give you the value of the B, but for the real design, firstly we give it each B and H. If the B, suppose the B is equal to 200, and then you should calculate if 1 layer 6 if it's big, 200 if it's big enough. So if it's small, if it cannot put 6, maybe you should make it 2 layer or something. You should think about. Now you can use your design because I can give you the value of the
B.
If you in the question give you the number of the B, you should think about it. If 1 layer you put 6 is wide enough or not. Because the space of the details and the cover thickness all have the requirement.
Okay.
Actually, it's
We can design.
you can design. What's your choice? What's your design?
I think there's a lot.
So this is the calculation. Once you got the area, then you check the table to select possible combination of the reinforcement. Yeah.
A bigger number than
Hmm?
a bigger number like 9,000.
Normally, it is if you use too large value, it's better to keep it not more than I think 10% or something like this. If you use too large number, that means actually one is you waste your material. 2 is if you put too much, maybe your design become over reinforcement. You can try, maybe 10% or 5% is okay, but if too much, maybe 30%. If the result is 7,000, maybe use 10,000 or something, maybe. Because after you select the diameter and the number, you need to check the reinforcement ratio.
Okay.
So maybe you find, oh, it's too large.
So it should really not be too large.
Yeah, I think normally 10% larger than this. Keep it in, keep 5% or 10% large is no problem at all. Because when we design, we need to keep we think about the economic point. We cannot waste the material, spend too much money. Yeah.
No way something. More, if there is more material, there is more space.
Yeah.
Non, c'est trop peu. C'est 7,200 euros. Là, tu as 7,200.
C'est 900
7,000.
C'est 900.
Alors, je dis
500.
7,000.
500.
7,000.
500, non, non,
So your design got some problem. See, for the large diameter, you just choose 5. For the 25, you use 7. So normally the number, the first layer should be cannot smaller than the second layer, or the upper layer normally is not larger than the lower layer, the number. So now in the basically the first layer you should put 5.
Like here.
Yeah.
So then 7 should be like the first.
Oh yes, maybe you can use this design and in the first layer use 532 and plus maybe 125, but it's not a good choice actually.
Il faut que c'est sombre, et puis il faut que c'est grand soit.
Ah, ça c'est normal.
No, when you choose this one, 32 must be down. The first line must be the greater the great number.
Normally it should be like this. Maybe yeah, if you have to use this design, you can use 532 at the first layer and maybe plus 1 or 2 25 in first layer. Normally the first layer, the number of the diameter, number of the reinforcement cannot be smaller than the second layer normally. What's your choice? You write this time?
Oh, okay.
No, you can write that too.
Yeah.
You just
Non, si tu fais ça comme ça, tu fais du quoi?
your area of the steel bar you use. And you also need to calculate the real H0. Then you go to the real reinforcement ratio to check this if you meet the requirement for the maximum and minimum requirement for the reinforcement ratio. This is the step 4, step F. Then checking whether the calculated AS is equal to the actual AS or not. If the error is large, the recalculation is needed. If the AS assumed is smaller than this actual, that means it's not a safety. So finally, you draw this arrangement for your section, how to arrange your steel bar. This is the first situation, the simple situation. Give the condition, just ask you to calculate the area of the reinforcement. The second condition is only given the external force induced moment MD and the material FCDFSD, asks you to do the design. Here included the size of the section you need to design yourself, and also calculating the area of the reinforcement. So now that means that this 4 parameter you don't know. For this case, we have said, for this case, the y section B, the pyramid B, is defined by the structure construction.